Welcome to this video on algebraic expressions. This is the second part of our lesson on this. Today we're going to talk about the parts of algebraic expressions, not just writing them out and translating them. To start with, we talked about this very important word called term. Okay, in math, the term is the number of variable or product of numbers and variables. So for example, a term could be a 2, it could be an x, it could be a 3y, or it could even be a 2x to the third, y to the second, z to the fourth. I mean, it's anything, basically a combination of numbers and letters, or just a letter or just a number. That is going to be a term. Okay, so knowing when a term begins and ends is important. Okay, so I think of it as, you know, it's glued together, it's clustered together of multiplication. All right, so addition and subtraction are the commas. So anytime I see an expression, I'm visualizing that addition sign or that subtraction sign as a comma in my list. So that would mean I've got 3 terms here. Okay, and remember, in this term, the 3 is a coefficient and the x is a variable. Okay, the 4 is the coefficient, the y is a variable, and then this last one, 7, is what we call a constant. And think about that for a second. It has no variable here, right? So no value is going to vary here. It's always going to be 7. Okay, so that's why we call it a constant, because it does not vary. All right, so we're taking these two expressions, 8 plus 5x and 8 minus 5x, and we look at the difference. We got 2 terms, 8 and 5x, 8 and 5x. And then the signs or the operation between them, addition and subtraction. So what's the same in both expressions? Well, the terms are the same, and what's different? The operations are different. Okay? So terms can be the same, just operations being the difference. All right, and then here we want to identify the number of terms and then the terms themselves in each algebraic expression. So I put a comma here. Remember, I'm seeing subtraction as a comma, so it's 4 minus 3x. It would be 2 terms, 4 and 3x. 4a minus 9 plus 3a is 3 terms, 4a, 9, and 3a. And then this is 4 terms, 7b, 9x, 3a, and 12. All right? Now, to evaluate an algebraic expression is very similar to evaluating a numeric expression. Again, evaluate means to find the value or to solve. But what's different about it is if we did not see this second part, like if I could somehow cover up x equals 10, and all I have is 3x minus 4, there is no way to solve this expression, okay? Because we don't know what x is. An order of operations says you got to do this first, and I cannot multiply 3 times something I don't know. But the key to unlock this is x equals 10. Now I can solve it. And remember, when I have a 3 next to an x, it means to multiply. So what I like doing is I put it in parentheses. So it's 3 times 10, which is 30, and then minus 4, which is 26. And that's what it means to evaluate an algebraic expression. You can only do it if you know the value of the variable. So here, 11 minus s, so 11 minus 2. 11 minus 2 is 9. All right, 10 minus z, well, z is 8, so 10 minus 8 is 2. And then d, 5 minus 2 over 4, which is the same as a half, so it's 4.5 or 4.5. And notice how I'm working my way down. I'm still not using that equal sign. All right? And then a couple more. 7 plus 5a, when a is 20, so I put 20 in the parentheses. 5 times 20 is 100. 100 plus 7 is 107. And then 8 over 4 would be 2. Now, I changed the numbers on this table so they're a little bit nicer to work with. But the idea here is we can be given several different values for h, because remember, it's a variable, it varies. So 2 in for h is 3 times 2, which is 6 minus 2, and we get 4. So we put 4 in this spot. Okay? And then I could put a different number in for my variable, because again, it varies. So I have to do it again. You might say, well, wait a second, didn't we just use this expression? Yeah, we did. Now it's a new number. So 3 times 3, which is 9, minus 2, which is 7. So 7 goes in this. And then do it with 4. 3 times 4 is 12, minus 2, which is 10. And finally, 3 times 5, which is 15, minus 2, which is 13. So we fill in a whole table. Okay, and I could have done these with these other expressions, but we didn't have time to. All right? Your assignment here is page 33. Do the odds, 1 and 3. Make sure you do A and B. And notice there's going to be 2 answers because they want 2 different situations. I want you to solve it for 4 shirts and for 10 shirts, both. All right? Same with this, 2345 and 5485. And then on the other side, on page 34, I want you to do 5, 7, 9, 11, and 13. All right? This is a little bit like what we did the day before, okay, where we translate this into an algebraic expression. Here is like what we did on the previous page. And here is what we did on the pages just before this, where we're evaluating. All right, so use your text as a model for this. The problems you see here are a lot like what we did through the week. Well, thanks for watching, and we'll see you next time.